Let's talk about evaluating logarithms. Once you understand the definition of a logarithm, evaluating one is pretty simple with easy numbers. The problem comes into is once we start dealing with larger numbers, fractions, as well as negative powers. It gets a little bit confusing. So that's why I wanted to compile my best examples of me showing you how to evaluate logarithms, so therefore you can understand how to do it on your own. They're all comprised inside of this video, and I hope you enjoy. Cheers. Welcome. All right, so in this case, what we have is log base 2 of 32. So again, what we're trying to do is determine, what 2 raised to what power is going to equal 32. So let's just kind of go through the powers, our base of 2. So if we have 2 to the first power, 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth, and I'll go to 2 to the sixth, and we'll kind of see if we can find our solution before that. But that's exactly what we're saying. We're saying 2 raised to what power is going to equal 32? Well, 2 raised to the first power is obviously 2. 2 squared is 4. 2 to the third power would be 2 times 2 times 2, which is going to be 8. 2 raised to the fourth power is pretty much what you're doing is taking your previous number and multiplying it by 2. So that's going to be 16. 16 times 2 would be 32. So therefore, we can see that 2 raised to the fifth power equals 32. That's what our logarithm is asking. So we can evaluate this expression as the number 5. Thanks. So anyways, if you have this, so in this case, if you do not have a base, then we will assume the base is going to be base 10. Okay? Now, I did give you guys in some notes of what exactly logarithms mean or what they represent. And what this would be is, what a logarithm is asking is 10 raised to what number is 10,000? That's basically what a logarithm is asking. So when you guys see a logarithm and you see this base and you see this number, what it's asking is 10 raised to what number gives you 100,000? Now, looking at it as a logarithm is usually probably pretty confusing. I would probably prefer to look at this as 10 as an exponential equation. 10 raised to the x equals 10,000. Right? In reality, what I just did was I just set I'm evaluating, right? So I'm trying to find the value that's equal to, trying to find a value so I can create a variable for that. And then basically what I'm doing is rewriting it in exponential form. So I think a lot of times when you're trying to evaluate a logarithm, it's easiest just to rewrite it in exponential form to solve. Yes?
Wait, did you say so when there's no base for the logarithm, you assume it's 10?
Yes. OK. So now, how are we going to do this? So I'm going to ask you a question. Nick, let's pick on you. If I have 2 to the x equals 2 to the third power, what is x equal to? Let's just give it a random shot. If 2 to the x is equal to 2 to the third power, what would you say x is equal to? 3. Kind of seems obvious, right? Well, the reason there's actually a rule which we call is the one-to-one property that makes that true. All right? But you guys can see it's pretty obvious. Now, these I do not have as the same power. You could say they're both powers. They're both exponents. But they don't have the same base. Correct? However, can I rewrite them with the same base? Well, 10 to the first power is 10. 10 squared is 100. 10 cubed is 1,000. So what would give me 10 to the fourth? Now, do you guys see how x equals 4? So therefore, 10 raised to what number gives you 10,000? 10 raised to 4 gives you 10,000. So therefore, our evaluation, this logarithm is equal to 4. Cool? Welcome. So what I like to do is just show you how to evaluate log base 3 of negative 9. You're not going to get a lot of these examples coming up because once we kind of go through this example, you'll be able to see that it's very kind of basic to be able to understand how to solve any of these when you're going to have trying to evaluate a logarithm for a negative number. So the best thing I can do is actually I'm going to take this expression and actually rewrite it as an equation so I can rewrite this in exponential form. And what this says is 3 to the x equals negative 9. So what we want to do is we're trying to find a value that I can raise my base 3 to equal a negative number. And the thing is, this is going to be impossible. So there is no solution for this. So let's just go and take a look and see, why is that going to be the case? Well, we know that 3 squared equals positive 9, right? So we could say, all right, well, what else? What about if we did negative 2 then? So if I did 3 to the negative second power, well, remember, by using your negative exponent, that just represents 3, or 1 over 3 squared, which is just going to be 1/9. So again, that's not going to produce a negative number. And then maybe you might want to think of, what about 3 to the 1/2? What if I made it a fraction? Well, remember, by using your rational exponent, that just represents the square root of 3. So either way, if you're thinking about this, when you're trying to produce multiplication and you have your base is positive, it's never going to produce, multiplying a number by itself is never going to produce itself into a negative number. Therefore, this example, or this expression, all right, is going to have no solution. There you go. Okay, for these types of problems, what I'm going to do is I'm going to show you a little bit of using these kind of helpful tips with logarithms. But before, these little helpful properties of logarithms, and they're going to help me kind of solve these logarithms, or at least evaluate these logarithms, I should say. But the main important thing you guys need to know about this is what actually is a logarithm. And I've gone through many other videos on what exactly a logarithm is, but very basically what a logarithm is it's an exponent. And what kind of exponent is if I say the log base 3 of 9, what that says is 3 raised to what value or what number gives me 9. And so this one's a pretty basic one. You could say, well, the answer to that is obviously we know it's going to be 2. Log base 3 of 9 is 2, because I can multiply 3 by itself twice to give me 9. Now here I have log base 7 of 1. So 7 raised to what number gives me 1? Now, if you're very familiar with your exponents, you could say, oh, well, that's going to be 0, because 7 raised to the 0 power gives me 1. And what you'll find out is that's actually true for all logarithms and all numbers, that anytime, it doesn't matter what our base is, anytime we raise it, or whenever we have our base and we're evaluating it for the logarithm of 1, it's always going to equal 0, right? So this answer is going to equal 0. Whenever you're taking the log, doesn't matter what the base is of 1, it's going to equal 0. Here we have a base that's larger than what we're evaluating for. So we need to start thinking about this and say, well, if 16 was raised to the first power, it'd be 16. If 16 was raised to the second power, it'd be 16 times 16, which is going to be greater than 16. So we need to think of a number that is going to be greater than 16. I'm sorry, that needs to be less than 16. And so therefore my exponent has to be smaller than 1. So I'm going to have to be dealing with a fraction. And a couple ways to kind of think about this is, well, one thing I notice is, 4 and 16, how are those related? Well, 16 is the square root of 4. How else can I write the square root? 4 is the square root of 16. How else can I write 16? 16 is the square root of 4. How else can I write the square root of 16? Well, you could also write it as 16 to the 1/2 power. The 16 to the 1/2 power is going to be the square root of 16. Okay? Then the last problem what I'm going to do is do log base 3 of 3. So to do log base 3 of 3, what you need to look at, again, I'm going to look at these two problems. And I'll have base 3 raised to the third power. So 3 raised to what number is going to give me 3? And you think about that, well, 3 raised to what number gives me 3? Well, the answer for that is going to be 1. And that is using those properties to evaluate for my logs. Welcome. So what I have here is log base 2 of 1/8, and what I want to do is be able to evaluate this expression without using a calculator. So what I'm going to do for this example is I'm going to rewrite this as an equation that's going to maybe help me kind of visualize this a little bit different in exponential form. So if I rewrite this equation, I want to find what this value is, so I'm just going to set it equal to x. Now, if I want to kind of get a better understanding of this, a lot of times we like to convert logarithms into exponential equations. So by rewriting this in exponential equations, that's going to be 2 raised to the x equals 1/8. So now what I need to do is say, all right, well, 2 raised to what power equals 1 over 8? And to work this as an exponential equation, a lot of times what we like to do is rewrite the exponential so they have the same base, if it is possible. So in this case, you can see here I have a base 2. Here I have a base of 1/8. Well, can I rewrite these using the same base? And if I think of base 2, how can I rewrite 8 as the same base? Well, first of all, here I have a fraction. Let's try to get this at least as an integer base. So if I rewrite this back as an integer base, I can have it as 8 raised to the negative 1 power using my properties of negative exponents. Now I want to see, all right, well, can I rewrite 8 as a base 2? And so we look at this and say, well, 2 cubed equals 8.
Pardon the interruption.
Sorry.
At this time, please release all 9th and 10th graders to the gym for the afternoon pep rally. Please also escort your class to the gym as well. Thank you.
So therefore, if I rewrite the 8 as 2 to the 3rd power, I can now, again, apply my power property of exponents. So I can say 2 to the x is equal to 2 to the negative 3rds. Now I have an exponential equation where the bases are exactly the same. I can set these equal. So now I can set my exponents equal to each other. So therefore, x equals negative 3. So when evaluating log base 2 of 1/8 without using a calculator, you can see my solution will be negative 3. Thanks.
All right, so it wants me to evaluate this logarithm without using a calculator. Now, some of you might be able to do this with your head, and that's perfectly fine. For those of you that cannot do it in your head, let's use our properties of logarithms to rewrite this problem. So since it's a division problem, I can rewrite it as multiple logarithms using subtraction. I don't like that marker anymore. Almost. So log base 5 of 1 minus log base 5 of 125. Now 5 raised to what number is going to give me 1? Well, you should know that properties of logarithms, any logarithm evaluated for 1 is going to give you 0 because anything raised to the 0 power gives you 1. And remember, that's what a logarithm is. What number 5 raised to what number gives me 1? Well, that's 0. Minus log base 5 of 125. So 5 raised to what number gives me 125? Well, that's going to be 3. So the answer is negative 3. And that's how you evaluate a logarithm like that, which you also could have done in your head. And if you check it in your calculator, 5 over, actually, let's just look at this. 5 over negative 3 equals 1 over 125. Really? Well, remember, I can always rewrite the negative exponent as 1 over the positive exponent. And is 5 cubed 125? Yes, sure. So therefore, it is true. It does work. 1/3 raised to what power gives you 27? If I'm ready to take it to logarithmic form and I rewrite an exponential, we need to figure out what number raised to the 1/3 power, or 1/3 raised to what power gives you 27. Again, we need to remember our rules of exponents. 1 over x to the negative m equals x to the m. All right, so one thing I want you guys to look at, if I keep on squaring this 1/3, I'm just going to keep on getting a fraction that's going to be larger and larger, right? Or as small as smaller. If I square 1/3, I get 1/9, right? If I cube it, I get 1/27. So that's not going to give me 27 over 1, which this is. So how do I get a fraction to be the whole number? I'm sorry. This is m, then I'll be there. Let's write it like that. So how do I get my fraction to be a whole number? Or I'm sorry, how do I get my fraction to be just a whole number here? What do I need to do? It has to be negative. That means my exponent has to be negative. Good. And then how am I going to get 3 to be 27? What exponent do I need to raise it to? Negative 3. So you can say x equals negative 3. And let's take a look at this. If that makes sense. Does 1/3 to the negative 3 power equals 27? Yeah, because then that's going to be 3 cubed, which is 27. Very good. Okay. Okay, what I'd like to do is show you how to evaluate a logarithm. And this is a logarithm when we have divisions going on. But one thing I noticed with this logarithm is I kind of have this 1, and I'm not really too sure what to do. So I'm going to show you 2 different ways we can solve this problem. And hopefully one of them is going to work. One way I'm going to use division, and the other way is I'm going to use multiplication. Now, A couple things we need to remember. One thing is, any number as a denominator can always be written as your numerator. I can write it back up on the numerator and just put it as to the negative exponent, okay? So what I can do for this problem, I'm going to do this two different ways. I'm going to first do this by actually changing my 5 to a negative 5 to the negative first power. So I'm going to say ln of 1 times 5 to the negative first power. Then here I'm going to solve it as ln of 1 over 5. Now remember, ln, we're going to have a base e, right? So that means, that's going to be my, my base. So using our two formulas, our two properties, for logarithms, that state whenever I have a multiplication, I can expand a logarithm by use of addition into two separate logarithms. So I can rewrite this as ln, not log. So I can rewrite this as ln of 1 plus, ln of 5 to the negative first power. And then here, you could also, whenever we're dealing with division, you could also write a division problem as a set of two multiple logarithms using subtraction. So I could write this one as ln of 1 minus, ln of 5. So, how are we going to get our answers? How are these going to be exactly the same? Because it seems like this one I'm doing multiplication, this one I'm doing division. How are they going to be the same? Well, there's a couple things we need to remember. Remember, whenever you have an exponent, you can put that exponent in front. And then there's another thing. Any logarithm, either natural or regular logarithm, whenever you're evaluating logarithm to 1, your answer is going to be 0. Because think about it this way. Log 3 of 9, that answer is 2. 3 raised to what number gives you 9? 2. Well, log 3 of 1 equals 0. 3 raised to what number gives you 1? Well, 3 to the 0 power is going to give you 1. So any logarithm evaluated for 1, no matter what the base is always going to give you 0. So here I can say ln of 1, e, right? We have this little e there. E raised to what number gives you 1? 0. Plus, I can bring my exponent in front. Right? Here, ln of 1 is 0 minus ln of 5. Okay? So here, all I have is a negative 1 times ln of 5. Well, I know that answer is just going to be a negative ln of 5. Here, it's a negative ln of 5. So that is just two different ways for you guys to evaluate a logarithm when using division. So, guys, we're just going to follow the rules of logarithms. So what it asks us to do is evaluate this log, all right? A couple things you guys have to remember. When using logarithms, we don't want to deal with roots at all. So we want to put them in exponent form. So remember, I can put an exponent up here inside my, in my radical, and that's going to be 8 to the first power. Then what I can do is I can rewrite this as log base 2 of 8 to the 1/4 power. And the reason why we always like using exponents when dealing with logarithms is because that property of logarithms states that whenever I have an exponent, I can take that exponent and put it in front, right? So now I can rewrite this as 1/4 log base 2 of 8.
So does the fraction basically cancel off the square root, kind of? Is that why you get rid of it?
I didn't get rid of it. I just put it in front. What do you mean? Or this is the same thing like if you want to type in your calculator, if I took like the square root of 16, right? We don't write the 2 there, but there really is a 2 there. All right? It's so common that we just don't write an 8. So if you want to type in your calculator square root of 16 or 16 to the 1/2 power, they give you both 4. So it's the exact same thing. When you're doing a square root, we just usually don't write the 2 because it's so common. So I rewrote this as 1/4. I bring it to the front. Now we just have to know what logarithms are. Remember, all logarithm states is 2 raised to what number gives me 8. And we know we can evaluate this for 3. So 1/4 times 3. 1/4 times 3, change that to numerator, multiply across. 1 times 3 is 3. 4 times 1 is 4. And that's my answer, 3/4. So there's a couple things we need to remember, a couple rules of logarithms, or just rules of exponents actually, that we need to know. First of all,
we do not like having radicals. Okay? So we need to remember mth root of x to the n. Anytime we have a radical, we can always rewrite that as a rational power. X to the n over m. So everybody remember that. It's not the first time we've gone over it. We need to remember this, though. It comes up a lot. Okay? The next one. We don't like having numbers in our denominator either. So 1 over x to the m, we can always rewrite it in the numerator, but just by using negative powers. Okay? Is everybody following with that? Okay, so let's go and let's make this not complicated anymore. Let's get this to 1 over 1,000 to the 1/2 power, because technically we don't write it, but technically there's a 1 there and there's a 2 there. Now, let's get this into the numerator. So we say log of 1,000 to the negative 1/2 power. So does everybody see what I've done? I've tried to make this simple, so now it kind of makes hopefully a little bit more sense. It's easier to work with. Now, the next rule that we talked about last class period was log base b of b raised to the x is equal to x. So what we want is we want our base to be the same as that base. But you might forget what exactly is the base of log. If it's not written there, what is that base? 10. Log of x is equal to log base 10 of x. So we could put in a little 10 there if we want to. Same thing. We don't write a 2 for the radical, but it's there. That's what that represents. All right? Now, our goal is the base and our value to be the same. So we want 10 and 10 to be the same. But we have a problem because that's 10 and that's 1,000, right? Just put it on the corner. So can we rewrite 1,000 as 10 raised to a power? Huh? Yeah, 10 to the third. So I'll write 10. I'll just leave that little 10 there so it makes more sense. 10 to the third power, and that's all still raised to the negative 1/2 power. Then we have to remember another property of exponents. X to the m raised to the n equals x to the m times n. That's called the power rule. Whenever you have an exponent raised to a power, you multiply the powers. So therefore, I have log base 10 of 10 to the negative 3/2. But now that it's written in this format, do you guys see how this nicely follows along this rule? So now the answer equals negative 3/2. You guys just put them down right there. Welcome. All right. I like this problem a lot. Just want to make sure I wrote it down. Yeah, I did. OK. So again, when looking at a problem like this, what we want to do is rewrite this as a rational expression. Now, a rational exponent. If I have a exponent here, or a radical represented by m, which is the root, and b, which is the power of my radicand, I could rewrite this as a rational exponent as b over m. So in this case, my 2 is being raised to the first power. Therefore, I can rewrite this as log base 2 of 2 to the 1/3 power. Now that I've rewritten it as a rational exponent, I can now use my property that log base b of b raised to the x just equals x. So therefore, that equals 1/3. So there you go, ladies and gentlemen. That is how you evaluate your logarithmic expression. Thanks. Welcome. So in this case, what I have is log base 6 of the square root of 6. And this brings an interesting question. How are we going to simplify this one when we're familiar with, if I had log base b of b, we know that equals 1. And if I had log base a of a raised to the x, we know that equals x. But in this case, I don't have the exact same bases. That's 6, and that's the square root of 6. And here, I don't have an exponent, so I can't say that it's a rewrite. I can just say that it's not going to equal just the square root. However, what I can do is rewrite my square root in terms of a rational exponent. So when doing that, I rewrite this as log base 6 of 6 raised to the 1/2 power. Now you can see I can rewrite this. Now I can use this property to therefore now evaluate my logarithm expression to 1/2. Thanks. OK, so what I'd like to do is show you how to evaluate 7 raised to log base 7
of 25. Now, the very simple answer with this is if we have x raised to the log base x of y, well, that's just simply going to represent y, as we can say these divide out. You might be, or simplify it, you might say, well, why does that, work? Why is this answer just going to simply be 25? So what I would recommend is, well, how about we just use some numbers that would actually make a little bit more sense if we had to evaluate for this. What about if I said 5 raised to the log base 5 of 25? And if I rewrote this problem in this case, our serial Israel, if I rewrote the problem in this case, what I would do is if I had to evaluate log base 5 of 25, we know that's going to be 2. So I'd have 5 squared, which just equals 25, right? So you can see when looking at this, when evaluating, you can simplify to rewrite this in as just what you're evaluating for when you have the log of your base being raised to that power by that same base, your exponent. So there you go, ladies and gentlemen. That is how you evaluate without a calculator. Thanks. Welcome. All right, so this one gets a lot of students, and I actually don't really commonly use this one, usually because a lot of times it's, to students, sometimes it gets a little confusing, to go through why is this going to be exactly the case here. And I think a lot of times it sometimes can even be expressed, by going back through our rules, our rules of exponents. So if we just look at the natural logarithms, one thing that we said is, ln e, a base e of e, we know is equal to 1. And remember that ln always has your base e, so we usually commonly do not write it in there. But then if I have ln of e raised to an x, then therefore it's just going to equal whatever my e, what power it's raised to. But that is also true if I have e raised to the ln of e, or the ln base of e. That's also just going to equal, if I say that's x, that is also just going to equal x. As here, sometimes we say that the base ln base e of e, that just leaves you with the x. Well, in this case, we have the exact same thing where it's just going to represent our x. So here, if you're going to look at this, what we simply have is e ln. Those are going to kind of undo our operations, and we're just going to be left with 300. So there you go, ladies and gentlemen. That is how you evaluate without a calculator. Thanks. Go off of the properties of logs. We know that by the properties of logs, if I have ln of 1, we know that is equal to 0, right? And we know ln of e equals 1. Those are just two properties that I want you to make sure you're aware of. All right? So now, ladies and gentlemen, if I say, well, what is this? How are you going to simplify this one? Well, the first thing we can do is we can obviously rewrite e over 1. So we can rewrite this as ln of e to the negative first power. Yes? OK. Now, what is ln of e? What's ln of e? 1. And then, I'm sorry, even don't go through this. We also have this. ln of e to the x equals x, right? So therefore, ladies and gentlemen, what is the base of this? E. So ln of e raised to the e to the negative first is just going to equal negative 1. So that's your simplified answer. OK? If you guys go and take a look at this, basically what we're looking at, Brianna, is trying to use our properties to evaluate. Basically meaning we're trying to get the value of this logarithmic expression. So Aaron, the first thing I'd like to do is try to see, can I take 2 raised to some number equals 160? I don't know yet. I mean, I could use my calculator. I could do guess and check. Nothing, though, that I've gone to. I've really only went up to like 2 to the 6th power in this class. And that gave us 64. So I don't know. I could keep on working on this and see if it gets to it. But I don't think it's going to be the case. 2, I know raised to what number gives you 5. Well, I know 2 raised to the 2nd power is 4. 2 raised to the 3rd power is 8. So this is going to be some decimal, right? However, if I apply the rules of exponents, I would have to do 160 divided by 5. Now, 160 divided by 5 is going to be 32. Hopefully, now you guys are a little bit more familiar with 2 raised to what number gives you 32. And that answer is 5. Well, when we have polynomials and pancakes, then we're having fun.
if you guys go ahead and take a look at this. Interesting. Did you do this problem?
What number?
This is question number 44.
No.
Huh? Oh, okay. So we'll go ahead and take a look at this one. So we'll expect to write the answer. All this one is evaluating. So you're using says use the property of logarithms to evaluate each expression. So we could do this a couple different ways. You could use the properties of logarithms, which would basically tell you to do log base 2 of 8 times 4. Log base 2 of 32. Do you guys agree? What is the log of log base 2 of 32? 2 raised to what power gives you 32? 5. You guys also just could evaluate each one separately. 2 raised to what powers is 8? 3. 2 raised to what power is 4?
Wait, how did you get that?
So you could do it either way. 2 raised to what power is 32? Yes. 2 raised to what power is 32? The answer is 5. Welcome. So what I have here is log base 2/3 is equal to 9 over 4. And man, this just doesn't look like fun. So a couple things. If I have, so again, we're raising things to a power. So let's just go back and review what happens when I raise a fraction to a power. Remember, that's a to the m over b to the m. But let's also talk about, what about if I raise it to a negative power? Well, therefore, I can take the reciprocal of that and raise it to the positive power. So therefore, it would be b to the m over a to the m. All right, that's going to become very important, because when I start looking at this as 2/3, I'm going to start raising it to a power. Now, obviously, 2/3 raised to the 0 power is just going to give me 1. 2/3 raised to the first power is just going to give me 2. So let's start at 2/3 squared and 2/3 cubed. See if that's going to get us anywhere. So therefore, that's 2 squared over 3 squared, which equals 4/9. Very close, but not exactly. And then let's do the cube. That will give me 8 over 27. All right, now my numbers, they're getting a little too far away, right? Oh, I'm sorry, that's going to be 2 cubed over 3 cubed, which equals 8 over 27. All right, but now how about we take a look at our negative numbers? So if I did 2/3 to the negative power, what that means now is I can take the reciprocal of that and raise it to that power. All right, so if I have the raise it to the negative second power, I can take it to the reciprocal and then raise it to the positive power, which would be 3 squared over 2 squared, which is equal to 9 over 4. So therefore, we look at this and we say, so 2/3 raised to what power is going to give us 9/4? Oh, I'm sorry. That's not equal. It's going to give us 9/4. That answer is -2. So there you go, ladies and gentlemen. That is how you evaluate a logarithmic expression. Thanks.